Okay, so here is a quick review on substitution, elimination, and equal value method. So if you're given these equations right here and I ask you to use elimination to solve them, we first need to think about how can we get these equations so that they're ready to go for elimination. So remember that we kind of talked about in class that we need to think about kind of how we did with fractions, how we think about common denominators. So we need to think about common factors of 3 and 2, or 3 and 2 in this case also. So we have options like 6, we have options like 12, 24. I'm going to choose 6 just so that it's a little bit easier. And you have your choice of deciding if you would like to eliminate your x's or y's. I'm going to decide to do the y's because they're already in opposite signs of each other, but you're more than welcome to do the x's as well. So I'm going to choose to multiply this whole entire equation by 2. And a little side note on why we're allowed to do that. If we think for a second, if 5 plus 2 equals 7, and that's true, if I go through and multiply all of this by 3, it will say 15 plus 6 equals 21. And that's still a true statement. So it's totally fine for me to come over here and multiply this all by 2 because it'll still keep the equality. So then we'll have 4 times x minus 6y equals 14. And then if I come up here and I multiply this entire equation by 3, we will have, and I'm going to move this down here so that we can see it better. So we're going to have 9x plus 6y equals 30. So 9x plus 6y equals 30. Okay, and when we're solving equations, to keep things balanced, to keep the equality, we have to think about adding the same quantity to both sides. So if I take this equation here, and I decide to add 30 to this side, I technically need to add 30 to this side of the equation as well. Well, if 30 equals this, then this is really the same thing as the number 30. So if I choose to add this to this side, I'm adding 30 to that side of the equation and 30 to that side of the equation. And when I do that, I'll have 13x plus 0 equals 44. Okay, and I obviously don't need to have the zeros there, but 13x will equal 44. And then from there I can solve for x and then plug in my answer and get my y. So that's elimination method there. Okay, let's move on to substitution. Let's say that I give you this problem and I ask you to solve using substitution. So remember, substituting is based on the idea that two things have the exact same value. So you're replacing the value of one with the other. So it's like if I say 2 times 8 equals 16, instead of saying 2 times 8 is 16, I could replace this with 2 times 4 times 2, because this is the exact same thing as this. So I could really say, instead of saying 2 times 8 equals 16, I can say 2 times 4 times 2 is equal to 16. Okay? Okay, so if we look here, you can choose whether you'd like to replace a y value or an x value. I'm just going to replace the x value in the first equation with the x value in the second equation. Okay, so I'm going to solve for x here. So I'm going to subtract whatever y is. So x will be equal to 5 minus y. Okay, and if x is equal to 5 minus y, and I have this x up here, and these x's are supposed to be the same so that these graphs have the same x and y, then I can just substitute this value in for x. So my new equation becomes 3y plus 5 minus y equals 13. And then I can go ahead and simplify that from there. Once I have my y equals, make sure that you go plug your answer back in to find what x has to equal. And then my last thing over here, what if I want to use equal value method on this? This again comes with the same equality. So here's an example of this. If x equals 3 and y equals 3, what does that mean? Well, if x is 3 and y is 3, and they are both 3, that means that x is going to equal y. I'm essentially replacing this 3 with that x, because x and 3 are the same. So instead of writing this as 3, I can write this as x. Okay, kind of an idea like substitution as well. So if we have a problem here and I want to do equal value, I'm going to see if I can get them both to be equal to y. So I've already got the second equation like that. I'm going to solve for y in the first equation. So subtracting 3x, and I'm going to move down here because I don't have a lot of room. So 5y will equal 9 minus 3x. And then we can divide by 5, divide by 5. So I'm going to stick this over here now. Y equals 9/5 minus 3/5 x. Okay, this is kind of a nasty problem at this point, but that's okay. So we know that y is equal to 8x plus 1 and y is equal to this. And if you think about it, it's like, well, how can y be equal to two different equations? Well, just think about it. 10 is equal to 5 times 2, but 10 is also equal to 9 plus 3 minus 2. Okay, so a number can be equal to multiple expressions. So whatever this number is, I can express it as 8x plus 1. I can also express it as 9/5 minus 3/5 of x. So if y is equal to this and y is equal to this, just like if 10 is equal to 5 times 2 and 10 is equal to 9 plus 3 minus 2, I can assume that 5 times 2 is equal to 9 plus 3 minus 2. They're both equal to 10, so they're both equal to each other. So we can do the same thing over here. X plus 1 will be equal to 9/5 minus 3/5 x, and that can be my new equation, and then I can solve from there and go ahead and plug in back for y. So hopefully that's helpful.